what they're testing. They want to know, do you understand the basics? Can you explain your decisions? Do you know why you use each technology? They're not testing fancy UI, perfect architecture, advanced patterns. Common interview questions and answers. Why did you use Redux? I use Redux for state that needs to be shared across multiple components. Specifically, I put authentication state, user session is authentication, and blog data in Redux because these are accessed by many components throughout the app. This prevents prop drilling and provides a single source of truth. Key points: shared state across components prevents prop drilling, single source of truth. So these are related to the auth slice.ts and blog slice.ts. So explain your Redux slice structure. So I have two slices. First, auth slice handles authentication state and async operations, register, login, logout, and check session. The blocks second is blog slice, handles blog data and CRUD operations, fetch blogs, create blog, update blog, delete blog. Each slice uses initial state for default state, reducers for synchronous actions, extra reducers with create async tank for async operations like Supabase API calls. So these extra reducers I have for this let's see, extra reducers for fetching blog, fetch blog by ID, create blog, update blog, and delete blog are all part of asynchronous operations like Supabase API calls. So this keeps the code organized and follow Redux Toolkit best practices. Key points, two slices, auth and blogs, async tanks for API calls, organized structure. So the protected route component, sorry. The protected route component, so I have that as a way for my React to check if it's authenticated. And if it is, it will check the slice. For that, I have export cons protected route children. Now I have if is authenticated, return navigate. So this is the React router redirect. And the cons is authenticated, use app selector state state.auth is the Redux state checks. How it works, it reads is authenticated from Redux slices. If false, redirects to login. If true, renders the protective component. Where it's used in app.tsx. In app.tsx, I have route paths bug create at line 30 to 35. So here it uses browser router and it uses dispatch check session before that, and it import all the use effect browser writer, use app dispatch from the store slash hooks, check session from the store slash slices, navbar from component slash navbar, protected route from component slash protected route, register from pages slash register, login from pages slash login, logout from pages slash logout, blog list from pages slash blog list, blog view from pages slash blog view, blog create from pages slash blog create, blog edit from pages slash blog edit. So I have pages for blog create.tsx, blog edit.tsx, blog list.tsx, blog view.tsx, login.tsx, logout.tsx, register.tsx. So those are all in TSX, are kind of React written up. So why Redux Toolkit instead of plain Redux? Answer: Redux Toolkit significantly reduces boilerplate code. It produces create slice, which combine actions and reducers, and create async tank for handling async operations like API calls to Supabase. It also includes best practices by default like Immer for immutable updates. So as you can see in my package.json, I have imported the Immer, which handle the immutable updates, which means that it may look that you are updating the database, but you're creating a new state in the back end using your reducer. So your reducer doesn't actually reducer is similar to function, or your function doesn't actually change the database, but instead it created a new state, like a new snapshot in while in column star and row oriented database. Now the action is like the use state of React. So key points: less boilerplate, built-in asynchronous handling, best practices included. What state did you put in Redux versus local state? Answered: I put global shared state in Redux. Authentication: user session is authenticated. Blog list data: pagination state, page limit, total, loading, and error state. So this is similar to, let's see. So Redux, similar to Redux, treats application states like a database snapshot. All changes are log applied automatically, replayable, and never mutate history. So reducers, first, reducers never mutate. What is actually meant? When reducer doc says reducer never mutates state, they return a new state. They're talking about observable state from the outside, not about what syntax you're allowed to write inside the reducer. The contract is this: very important. Given previous state, comma, action, reducer produces a new state snapshot, and the old snapshot is never modified. That is the rule Redux enforces. It does not mean you can write assignment. You can write state.foo equal bar. Those are implementation details, not the contract. And first, let's fix the misunderstanding. Important. Does Redux handle mutation like CPU handle cache coherence in code? No, not literally. Redux does not manage CPU cache lines, influence Supabase CPU, participate in out-of-order execution, interact with registers. Redux lives entirely in user space JavaScript. What Redux does is enforce constraints on how you're allowed to mutate state so that higher level guarantees become possible. This is the same design philosophy used in CPUs and database, not the same mechanism. Think Redux is to application state as SQL is to storage engines, as ISA or ISA is to CPU microarchitecture. Declarative interface, engine hidden underneath. What Redux actually does internally, no analogy. Let's strip Redux down to its actual core code behavior. At heart, Redux is just this: function create, store, argument reducer, open semi-curly bracket, next line let state, then next line let listener equal empty array. The next line function dispatch argument action, open semi-curly bracket, next line state equal reducer, argument state comma action, next line listeners that for each argument 1 2 1 open and close parenthesis, open semi-curly bracket, next line function get state, Open and close empty argument, open semi-curly bracket, next line return state, next line closing semi-curly bracket, next line return, open semi-curly bracket, dispatch, comma, get state, comma, subscribe. Closing semi-curly bracket, closing semi-curly bracket. That's it. Everything else, toolkit, immer, devtools, stunks builds on this. Key internal funcs, there's one state object. Every dispatch calls reducer. So the dispatch on our app is actually what calls the reducer. It creates the new state and replaces the old reference. Kind of how it would change it to a new state, or how would it create a new state instead of updating the old one. Reducers are just pure functions. Redux never mutates, it replaces. No magic, no CPU tricks. Why reducers must be pure? This is the real connection. Now we connect to CPUs, databases, SQL at principal level. Why CPUs require controlled side effects? Out of order execution only works if instructions don't secretly modify global state. Effects are reorderable, replayable, discardable, and rollback. So by having instruction not secretly modified in global state, you're kind of mimicking that in a principal level for Redux in not enabling mutation at the user level space. That's where registers are renamed, memory writes are buffered, speculative results can be thrown away. If instructions had controlled side effects, speculation breaks. Now let's go to what state did you put in Redux versus global state? Since we put the authentication user session is authentication, those are the domain state or global domain state. So meaning those are data that change over time that's not related locally. So it's different from UI level components or local state in components for form inputs, title, content, file input states, UL only flags, model, open, close, and image preview, because this separation keeps the code clean and makes it clear what state is shared versus component specific. Kind of mean a centralized long-lived domain state to reduce coordination complexity and reduce deterministic updates. So control state versus domain state. Domain state represent facts, long-live, shared, must be consistent. Example, blogs, users, session. Control state or govern transitions, loading, error, pagination, fetch status. It's kind of like a program control unit in CPU microarchitecture. In databases, domain table, state to tables. The main state is tables, control state is the transaction state, locks, while pointers. In CPU, domain is the registers, control is the program counter, flags, pipeline state. In Redux, domain is blocks.items, controls is blocks.loading, and blocks.error. So why blog list is the main state, not UI state? This is critical. UI state answers how should this component look right now. Examples, model open, input value, image preview. The main state answers what does the system currently believe is true. Example, who is logged in, what blogs exist, what page of results exist. So it's like a system level truths. So who is logged in, what blogs exist, what page of results exist, whether data is loading or failed, how would it trigger the page list, etc. Or the paging. A blog list exists independently of any component. Vibe navigation is shared across screens, is constrained by business rule, has life cycle beyond rendering. That makes it the main state. Just like a table is not a UI concern, A column is not a UI concern. A cache line is not a UI concern. So this is how it maintains the state. Key points: global equal Redux, local equals to use state, clear separation. How does authentication work in Supabase? Supabase handles authentication server side. When a user registers or logs in, Supabase validates credential and returns a session with a JWT token. So I store this session in Redux. For subsequent API calls, Supabase automatically includes the token in headers. So that's how you automatically make the that state persistent across of the user session. So that's where your session in the slice.ts means. So for subsequent API calls, Supabase automatically includes the token in headers and the backend validates it. Row-level security RLS policies ensures user can only modify their own data. Key points: server-side validation, JWT tokens, automatic token inclusion RLS for security. So the key here is the automatic inclusion of the slice.ts asynchronously calling the Supabase. How did you implement validation? So I use Supabase.range method to fetch a subset of records. So this is a Supabase.range method that will trigger the PostgreSQL database that fetch a specific subset of records. For example, with page 5 logs per range, page 1 records 0 to 4, range 0, 4, page 2 range 5 to 9, range 5, 9, page 3 records 10 to 14, range 10, 14. So I store the current page and total count in Redux and calculate the range using from page -1 times limit and 2 from plus limit -1. So those are included in blockslice.ts. So this limits data load and improved performance. I implemented pagination using Supabase that range from to method. The formula from equal page -1 times limit calculates the slice for each page minus page 1 gets record 0, 4, page 2 gets 5 to 9, etc. So I store pagination.page and pagination.total in Redux. This centralizes the coordination. When a user clicks next page, a single dispatch updates the page number, triggering fetch blocks to calculate the correct range. Redux ensures this update. It's the deterministic and atomic all subscribe components. Pagination controls blog list URL state and see the same page state simultaneously. Key points: Supabase.range method, formula page -1 times limit, performance optimization. How does image upload work? When a user selects an image, read the file locally to show a preview. On form submit, upload to Supabase storage bucket, block image. And then third, generate a unique file name using user ID and timestamp. Fourth, get the public URL from Supabase. Fifth, save the URL in database with blog post. The storage bucket is set to public for reading, but only authenticated users can upload. The URL is stored as image_URL in the blogs table. Key points: Supabase storage, unique file names, public URL storage, authentication required for upload. Why TypeScript? Answer: TypeScript provides type safety, which catches errors at compile time rather than runtime. It makes the code more maintainable and self-documenting. For example, I define interfaces for blog and user, which ensures type consistency across the app and provides better IDE complete. So Here's where your TypeScript interface live in supabase.ts. So you have data types in supabase.ts, export interface, blog, ID, title, content, image underscore URL, user underscore ID, created underscore at, updated underscore at. So how this provide type safety to your app? So it compile time error catching. So blog slice.ts that kind of communicate with that supabase.cs. We have import supabase, comma blog in live slash supabase.cs and interface blog state. So blogs colon blog empty array type safe array and then current blog colon blog can be null. Now if you try to set wrong type, state that blogs like title colon 123 TypeScript error cannot assign title 123. Better IDE complete in blog list.tsx. We have blog.map, blog, div key, blog.id, blog.il. IDE knows blog.title exists, shows autocomplete. Without types, you get no autocomplete. Self-documenting code. The blog interfaces shows exactly what fields exist and their types, no guessing. Use in async tanks. Blogslice.ts. So the blog interface shows exactly what fields exist and their types, no guessing. So this is how you use TypeScript in supabase live slash supabase.ts. Inside your SRC. So blogslice.ts export const fetch blogs, create async tank, async page. So that means TypeScript knows the data returned from Supabase's blog and return blogs data type set return. TypeScript catches mismatch at compile time, not at runtime when user sees bugs. So it makes the code more maintainable and self-documenting. For example, I define interfaces for blog and user which ensure type consistency across the app and provides better IDE complete. Key points, type safety, compile time error checking, better IDE support, self-documenting code. How do you protect routes? Answer. I created a protected route component that checks if the user is authenticated using Redux state. If not authenticated, it redirects to the login page using the React Router's navigate component. So again, redirect using the navigate component. And protected route checks if the user is authenticated using the login session in the slice.ts. So now I wrap protected routes like /blog /create and blog /edit /ID with this component. Key points, component based protection, Redux state check, React routers redirect. Explain your Redux slice structure. So answer, I have two slices, so we're just repeating it. Number 10, what happens when a user creates a blog? Answer, user fills out the form, title, content, optional image. If image is selected, it's uploaded to Supabase storage first. Then third, the create blog async tank is dispatched. So the dispatch is related to reduce, which is related to function. Fourth, it gets the current user ID from Redux auth state. And then fifth, insert the blog into Supabase database with user underscore ID. So notice it gets the user ID from the Redux auth state to check if it's logged in or not. On success, the new blog is added to the Redux state. User is redirected to blog list. 8. The pagination total is updated. Key points: form submission, image upload if present, database insert, Redux state update, navigation. Now the flow example, user try to access, for example, blog /create. So this is related what happens when creates a blog. User navigates to /blog /create. Then second, app renders protected route component. Then third, protected route reads Redux state that is authenticated. If false, navigate to equals /login, replace greater than executed. Then fib, browser redirects to /login. If true, renders blog create.